times a to the power of half, what do you get? A to the power of 1. So another way to look at this is if I have square root a, which is power half, times square root a, that gives me a. The square root disappears. Okay, so this is one important property of 3.1, but it's derived from your indices law. Same thing. What if it's a to the power of half times b to the power of half? What do I get? AB power half, right? Because we had this, if you can still remember, a times b, and then if it's power n, both of them should get power n. So this is the reverse. This is also your indices law. So this tells us that if I have two surds, two different square root, two different radicals, if I multiply them together, I just combine them under the square root. That's all. So this is your 3.1 second property of surds. So all these are nothing new. It is derived from your indices law. Same thing if it's a fraction. You know you can write like this. So if it's square root a divided by square root b, is as good as square root a over b. That's all. This is your third property of 3.1. So everything is from indices law. That's why it makes sense to learn after indices. Can? Can or cannot? Can ah? Okay, one more thing that is important for indices is this difference of squares property you learn in Sec 2. Okay, if you all can still remember, a square minus b square is a plus b, a minus b. Okay, so if you want to get rid of an expression with surds, example, if I have 2 plus square root 3, I want to get rid of the square root in this expression. What I need to introduce is its opposite, which is 2 minus root 3. Can you see this is your a plus b? This is your a minus b. So what will happen? You will apply a square minus b square, and then your square root disappears, become 1. Can you see that? So this is the most important property that we will use, or rather identity that we will use in surds. So whenever we want to get rid of square root, they use this word called the rationalize. You want to make it into a rational number. Any number, most of the number with a square root that cannot be simplified, they are irrational. Okay, so how to rationalize it is to make it become a rational number. Okay, rational not as in logical, but any number that can be expressed as a fraction is called a rational number. Okay, so when we want to get rid of the square root, we are trying to rationalize it. Think about difference of squares. Okay, so this is the main point of surds. Wherever we are going, it will revolve around these three properties and then the difference of squares. Okay, so this is the overview. This is the thing that is important in the whole chapter. That's all. Okay, right. Alexa taking photo. You need me inside?
Yes.
Done? Okay, so I think in Sec 1 you have learned irrational numbers like your pi, your square root 2. Any numbers that cannot be changed to a fraction is an irrational number. So this one you know, you learned before. Okay, let's look at this one. So this one, I told you already, right? I explained to you already. So these are the three properties that we will leverage upon when we simplify surds. So these three. So first thing first. First question, if square root 3, I ask you to square it. It basically means root 3 times root 3, which is just 3. Another way to look at it is this is 3 to the power of half. If it's separated by square, we multiply the power. So it also gives me 3. Okay? So this is an application. Oh, this one got a blank. It's called a surd. Okay, I missed that out. Okay, next one. This one, they say, can you simplify square root of 12? So when we want to simplify surds, we want to split it up according to perfect squares and no perfect squares. So if you look at it carefully, 12 is 4 times 3. And the 4 is a perfect square. So I can actually split it up into 2. And then square root 2 is 2. Square root 4 is 2. And then it's just 2 root 3. Okay, I cannot simplify root 3 any further. So you can just leave it as it is. Raj, why you sit there?
I can't see well.
You can't see well, so you move back. Are you being rational? Yes?
Plus or minus 2.
Plus or no, because this is a positive square root 4. Whenever we solve a number, right? When we apply square root, we have 2 possible answers. But when we straight away do a positive square root, we ignore the negative already. Don't need to consider the negative part. Okay, so this one is positive square root. Don't have negative. Okay, this one. I want to split this up. So you look carefully, root 3 times 24. Is there a way I can split 24 up? 3 and 8. Can I bring in a perfect square? 4 and what? 4 and 6. Okay, so I'm going to split this into 4 and 6 first. So this is 2. I'm done with that. Is there a way to split my 6 so that I can simplify further? 3 and 2. So I'm going to split this into 3 and 2. So this root 6, I split it into 3 and 2. And then this one can simplify. Become what? What is root 3 times root 3? Just 3. So this one becomes 3, 2, and my root 2 remaining. So my final answer is 6 root 2. Yes. Square root 4 becomes 2. Perfect square, when you square root 4 is 2, right? So you can simplify. So we want to always bring in perfect squares because when you take square root, it becomes a nice number. Okay, what about this? How to split? How can I split my 48? How can I split 6 and 8? So my root 6 cancels out. Okay, how can I split my 8? 4 times 2. So this one I cannot change further. It is the simplest I can get, but this is just 2. So you end up with 2 root 2. Okay, this is breaking it up so that it is in its simplest form. Okay, what about this? So you can help yourself by writing this 3 times. And then 2 of it, the square root will disappear. And then this one is just root 6. There's no point in splitting 6 into 2 and 3 because it doesn't simplify it further. So you can just leave it like that. Yes?
So if you're dividing like the square root and both different numbers, we bring the like what number do we bring into that?
if we can make the exact same number, we will bring out the same number. Yeah.
But what if it's different number?
Then bring out perfect squares so that you can simplify. Yeah. Okay, so these are the simple rules. The 3 rules that were mentioned up here is what you apply to simplify surds. Can? Can you too focus on the screen means something else is on the screen. Y'all don't want to learn in class. During holiday, you work harder. You learn from SLS. Okay, so these are some shortcuts. Okay, this one, just further practices. So first thing first, number with number. So number with number, that's a 6. Root 6 and root 12. Is there a way to simplify it? Can I break the root 12 further? To become what? 4 and 3, but I cannot get rid of the root 6. So it's better to split it as root 2 and root 6. Okay, I will split my root 12 into root 6 and root 2 so that this thing here can simplify to be 6. Can. So you end up having 36 root 2. Okay, so pretend root 5 is an apple or an X, right? Just pretend that this is like that. So how can you simplify it? 2 apple plus 5 apple minus 3 apple is, count so long? 4. 4 apple. So instead of apple, right, root 5. So just treat it as an algebra. Like the root 5 is a object. Okay, if it helps you to see better, you can take out the root 5. So 2 plus 5 minus 3. Then you will also get this. Okay, but not needed. You can straight away simplify like that. It's like you have 2 root 5, you have 5 root 5, and you have 3 root 5. Just simplify them. Okay, this one. Next one. If you look at 2, 8, and 50, what is the simplest root number they can break down to? This one? You just pretend that all these are x. So it's like 2x plus 5x minus 3x. Then put back the x as root 5. Okay, so how to simplify these? They all look different. Make what into what? Can I make this into root 2? 1 root 4 and root 2. Okay, I can also make this to involve root 2 by making it to be 2 times 25. So the rest I keep where they are. Okay, so root 4 is just 2. So 2 times 6 is 12. Okay, root 25 is just 5. So 5 times 3, 15. Okay, so this is another question similar to part C now. Now we all have root 2's. 3 of it minus 12 of it plus 15 of it. So what do you get? What do you get? How many root 2 do you have? How many root 2? 3 of it. Take away 12 plus 15 of them. What do you get? Why very stunned, huh? 6 of this. Okay, so just treat them like x. Like as if this is just x. Like as if this is just x. Okay, how would you simplify them? Okay, this one, just expand them. 2 times 2 is 4. 2 times root 3, 2 root 3. Then we have 3 times root 2, root 3 times 2, another one. Root 3 times root 3 is just 3. So total, which one? This one. Okay, one more time. 3 root 2. Cannot simplify anymore. Root 8, I can simplify into root 4 times root 2. Correct? So this is from root 8. This 50, I can split it into 25 times 2. So this is from root 50. Okay, but if you calculate, root 4 is just a 2 in your calculator. Okay, and then root 5 is just a 5. Root 25 is just a 5. So if you simplify,
You get 6.
so if you find it difficult to visualize, I copy wrongly. So it's 2. If you find it difficult to visualize, take out the root 2. You'll be left with 3 minus 12 plus 15. So that's why you get 6 root 2. Okay, so always break up the big numbers into smaller parts. Okay, this one if I expand normally and I simplify, 4 plus 3 is 7. And then 2 root 3 plus 2 root 3 is 4 root 3. Done. Cannot do any further. That's all. No need. So you just simplify it to the simplest form. Cannot divide further. Then you just leave the answer alone. So your search answer is exact. All these answers are considered exact because you don't have to do any rounding off. Okay, this one same thing. Repeat these two and then you expand. So root 2 times root 2 is 2. Root 2 times 7 is 7 root 2. 7 times root 2, 7 root 2. And then negative 7 times negative 7 is plus 49. So if you simplify the numbers, it's 51 minus 14 root 2. Cannot. Why you all look like the brain is not functioning?
Hey, Matilda.
Like like when I look at your face, it looks like it's loading. Like hang. Okay, so this one you can try on your own. Try on your own. Toyo. Okay, all this you try on your own. Okay, I want to try on your own. Try on your own. Short form. Okay? So anyway, this one, you can split into root 4 and root 3, which is a 2 root 3. Okay, the rest, so if you can see, in the bracket is a 3 root 3 now. So you will get 15 root 3. Okay, so I'm just showing you how you can simplify. Okay, what about 27? How to split? How will you choose to split it? Try on your own. 7 and 9 and 3, you mean?
21 or 27?
27.
Oh, yeah, 9 and
Okay, 9 and 3. And then 12, I will do 4 and 3. What about 75? Find a perfect square. Root 3. Yeah, but what's wrong? Because this one has bracket. So I just copy down only. It means multiply. What is inside the bracket. So I only try to simplify this one. Then I simplify the bracket, then I multiply it. Yeah, so this one become 2 root 3, right? But plus 1 of it. So you got 3 root 3 now. Okay. Okay, 75, we will split 3 times 25 because 25 is a perfect square. So let's try to simplify this. Root 9 is 3. Okay, all these perfect square, go and simplify it. So root 9 is 3. Root 2 is 2. Root 25 is 5. So if you simplify 3 plus 2 minus 5, there's nothing left. Can. It's like 3x plus 2x minus 5x is nothing. What about 200? How will you split? 25 can, but is there another number bigger? 100? 102. What about 80? What about 80? Is there a perfect square? 16 and what? 5. Okay, what about 48? 16 and 3. So always try to split it up into the biggest perfect square possible, so that you don't have to simplify so many times. Okay, so the 100, the 16, all can change to whole number. So 3 times 10 is 30. This is 4 root 5. And then this is 4 times 3, 12. Okay, these 3 are apple, orange, and pineapple. So cannot simplify further, leave it alone, like your algebra. 3x plus 30x plus 4y plus 12z. You cannot simplify anymore. Just leave them as it is. Okay? So this is the simplification. Okay, so I hope you understand. If you have a big number, a big cert, always try to split it up into the biggest perfect square possible. Okay, to make sure your holiday... tomorrow I still... But tomorrow I may not do certs, right? Okay, let me think. I try. But if cannot, we do certs lah. Yeah. I try. Okay, let me do a quick... All this you toyo Okay, all this you try. You have the whole March holiday to slowly try. When you come back, I will go through. Okay, I want to talk about how to rationalize. Rationalize means you want to get rid of the square root in the denominator. You want to make it into a rational number. So how to get rid of this root 3? We cannot square the fraction, but we can multiply numerator and denominator by the same thing. So we multiply by root 3 for both numerator and denominator. You end up having this. Can you see that your denominator has been rationalized? That means it has become a rational number. No more surds, no more square root in the denominator. So this is called rationalizing. Okay, what about this? Just now we say, right, we can introduce the other pair so that we can get rid of the surds. So what should I introduce? 2 plus square root 3. These two are called your conjugate pair. Conjugate surds. Okay, it is a term to say that these two pairs are opposite of each other, and when you multiply them, the surd disappear. It's just some technical terms, okay, but basically this is what we are doing. So how can I magically get rid of the surds now? At the denominator, I will be applying a square minus b square. So it becomes 2 square minus root 3 square. I'm just applying this. And then at the top, so can you see the denominator now has magically changed to a number? Yeah. So it's math magic. Okay? So anyway, it's over 1. No need to write the over 1 already. But can you see that the denominator has no more surds? So this is called rationalizing the denominator. Okay, so I just give you like a teaser. This March holiday, you will go and explore on your own. There's a whole lot of video on SLS that you will watch and try to complete this during the March holidays. Yeah, the whole set of notes, it's your holiday homework.
Including PMP.
PMP cannot, man. One like that. Okay. Okay, then I tell you what. You just complete the notes. No need to do the PMP. It's a very big compromise.
So it will be 7 times 4.
28. No, 4. Yeah, right. 28. Right. Okay, that's it. Hope I have good news for you tomorrow. Hope. Okay, thank you, class. Hey, go and eat, go and eat. Is half times base times height. So my objective is to find the height. So first thing I do is I will divide by half. When you divide by half, it's as good as multiplying by 2. So I will just multiply the area by 2 so that my half disappears. Okay, so this is done. And then I also need to get rid of the base. So what do I do? How do I get rid of this base? I bring over and divide. So in order to get height, I need to multiply my area 2 times and then divide it by my base. So this is as good as a fraction that you need to rationalize. So when you are given a question like that, you are expected to rationalize. So before that, let's simplify first. Okay, and then we will rationalize it because question wants your answer not to be in fraction form. So you introduce its conjugate pair and rationalize it. So next step, you get a a square and this thing square at the base. So this is the crucial step. Okay, the next few parts is just your normal expansion. Okay, what is 18 times 8? Okay, cannot trust my brain today. 144. Then 18 times 4. 72. 64. And 32 times 3. 96. Okay, so you will get these 4 terms, which finally simplifies to okay? So the question is, they want you to leave your answer in this form, not in fraction. So let's try to can. Okay, so let's try to simplify this by splitting this into 2 fractions. Okay, so this is your A and this is your B.
Where the 16 go?
136 divided by 16.
Where the 16 suddenly gone?
This one, I split them into 2 fractions. So that I can simplify it. You cannot, because it's an expression. If you multiply by 16, the left hand side of the equation also need to multiply by 16. Yeah, so you cannot do that. Yeah. Why you nothing. No, you sounded like some cartoon character from some very familiar. I need to find it. Yes. Toilet? Yeah, can. Ben suddenly raised his hand. I panicked. Thought got something wrong. Okay, all good. Like got something wrong. Don't know leh. Is it Zootopia? I never watched much cartoon. The Hoppers. No, got one say pond rules. Then you sit on the pebble and wait to be eaten. Yeah, the pace. Okay, maybe that's why I was so familiar. Yeah, cause once you become a mom, you have no rights to choose the movie you want to watch anymore. Okay, next one. Which one? This one is the height, no? The whole thing we have been finding height. So this thing is the height. Okay, in cm. This whole expression is your height in rationalized form. Yes.
How do you know which one to put on top and which one to put on?
You look at the area formula, this one. So when you try to simplify it, area is on top. Yeah. Okay, let's move on to 3.2. I told you certs is a very, very short chapter. You just need to learn the important properties. Then you. Okay, so this one, right? This one later during lesson, we'll find some time to do it together. I know today is your CCA day, then you will whine. So this one we can do it together later. Do all, because both of them share the same denominator. Okay, this is exactly the same. So I can combine them into one by writing this. Okay, so I'm just combining the 2 fractions. But at the denominator, do you see this? So actually, okay, so denominator, Okay, so the bottom will be a square minus b square. I can just simplify it already. So the normal, this is root 12, root 18, 2 root 2, 2 root 3, root 6, and 3. At the bottom is 2 minus 3, which is negative 1. Okay? When you divide by negative, you reverse all the sign that you have above. So this one divided by negative become negative root 12. This one become positive. This one become negative. This one become negative, negative, negative. And then your negative one disappears. Okay, so now it's about simplifying. So this one I can simplify some more. This one is root 4 and root 3. This one is root 9 and root 2. Okay, the rest, there's no need to split any further. So this is minus 2 root 3. This is 3 root 2. Actually, you don't need to copy anything.
Oh no, this one I do.
Okay. Then you realize that this one,
It's the volume question and like the word problems.
okay. So this is minus 4 root 3. Between these two, you'll be left with root 2. And then the rest are all different. Just keep them as it is. No need to force them together. So this is the final answer. This question 4. Huh? Question 5. Who has finished and can do all the questions? Check already. I can pass you the next worksheet first so that you won't be bored. Regret to raise your hand, right? Yeah, no lah. Anyway, you need to do one. This one is homework, yes. So you, okay, because you all already know, then at least won't waste time, right? You finish this one already? You never show anything you want to take? Do you have the notes take out? You can do on any empty space or Pusket. Yeah. Okay, so that when we go through, you won't be bored. Where's your notes even? You tell me you did it, but you forgot to bring. Finish already, huh? Yes, this is homework. Do you have the notes? Ravan, do you have the notes? Do you have the notes? You just never bring. You don't have them. So why do you have the? Then where is it? Do you do your PMP? Then don't have. No. Take out. Okay, the feedback so strong. Okay, let's look at next one. Question 5. Okay, take this as revision for the quiz later. Yeah. Yes. Like the what? Now we are refreshing.
Now is the time you should be taking notes if you don't understand. Now is the question.
Okay, this one yesterday I told you all right. What you can do is to make them the same. So for the first expression, you can put in your root 3 minus root 2 square. Okay? And then for the second expression, you put in the opposite. So can you see at the bottom, right? Both of them share the same denominator. So I can combine them into one. Okay, so the denominator is actually quite special looking. Can you see that you have a plus b, a minus b, and then you actually square them? It's the same thing. Yes. Oh, okay, sorry. I should swap this over so that they are the same. That means instead of writing this, I should write it this way so that this is this. Shouldn't the on top have 2 times? Oh, I forgot. Okay, so this one will have 1 term. Okay, my bad. Okay, you haven't get your tea bag. Okay, the 3 of you don't have, right? Okay, I will go and get. Yes. Question 5. Okay, so the bottom, right? This 2 is actually the same as this. This 2 square is the same as squaring both of them. So what is this? This is a square minus b square. And then I square the whole thing. So my a square is this. My b square is this. And then I actually have to square the outcome. So numerator as per normal, expansion shouldn't be a problem for you. Okay, this one I think you should keep it first and expand this one first. So this will be 2 plus root 6. Which one? I make them have the same denominator. Oh no, this one is like that. Can you see that you just, okay, if you ignore the square, there are a plus b, a minus b, right? But you square the whole thing. So actually, if you don't look at the square first, you just focus on the inside, is this thing. So leave the square outside first, go and simplify, then you square the result.
The thing isn't the a plus b, a minus b, it's the a plus b squared.
No, this is a plus b, a minus b, what?
Where?
This a, this b. A, b. Isn't this a minus b, a plus b?
But then where do you get the a plus b?
I multiply in so that I can make them the same.
But then you would need 2, right?
Yeah, so I multiply it or the square. I miss out the square, my bad.
Oh, so you multiply the square root?
Yes. Can I?
So on top we also multiply it?
Yes. Okay, I will show you the other way if you find this tougher to understand. The other way is to go and expand the denominator first, simplify it, then rationalize. That is the other way of doing. Okay, so this one you just do. So at the bottom you will have 1. So the denominator is as good as nothing. Okay? And then you go and simplify the top. This is actually 5 minus 2 root 6. This is also 5 plus 2 root 6. Okay, and then you go and simplify them. 10. Okay, will O level be so tedious? Actually, no. Because you are practicing, Practicing must do tedious work. Yes. Cancel? Oh, no, I'm not cancelling, I'm simplifying to this. That means I change this to this. I'm just simplifying it. And then this is 2 root 18. Okay, the rest is just simplification work. This one will cancel out. This one will cancel out. So you're only left with 20 plus 4 root 18, which you can simplify some more. So it's 20, 12 root 2. Okay, for those who don't like this method, you find it too complicated, then you can go and simplify your denominator first. That means go and simplify this. You will end up having 5 plus 2 root 6. Here, same thing. Go and simplify the denominator. You will end up having 5.
If you do this, you get the a plus a squared plus b squared.
Correct.
Square being
Yes. Okay, so you will simplify your original expression to be this, then you go and rationalize. If this is easier, you do this. Okay, you can do this. Then go and rationalize like that. Yes. Yes. Okay? So this one you can also do the alternative way. Can So eventually you will end off with 22 root 3 minus 22 over 27 minus 16, 11. Okay? So if you divide by 11 throughout, you'll be left with 2 root 3 minus 2. So this is your breadth. So with the breadth and with the length, to find perimeter, is just 2 length plus 2 breadth. Okay, so just simplify. 6 and 4, 10. 8 and minus 4 is 4. So this is your perimeter, cm. Okay? Okay, next question 7. Okay, I just draw, I don't talk first. Okay, this is volume of cone. Formula given on the first page of your exam for E-math. A-math not given. Okay, so volume is 20. If you divide by 1/3, it's the same as multiplying by 3. Keep change flip, right? So this is multiplying by 3. So this is gone. The 1/3 is gone. Divide by the pi and divide by r squared. So this is how you get h. Can or cannot? Why the two of you got crown?
I don't know, I found it.
You are the beaver from Hoppers. They all watch the movie.
Yes.
The king, is it? I don't know what's that called.
Oh. Bro, I just found the colors.
Okay, so I repeat one more time. To find height, I need to divide by 1/3. But divide by 1/3 is the same as multiplying by 3. And then I need to divide by the pi r square also. So that's why the equation has a pi r square here. So 60 over pi and then my r square. So I go and simplify my height. This is a square plus 2ab plus b squared. So my expression should be simplified to be 9 plus 4 this. So this is my height. Okay, then question say, can you find the height of the cone and write it in this way? So they want you to rationalize. So to rationalize, you multiply by the opposite. Now, okay, wait, let me finish this. Okay, so rationalize. Okay, at the bottom is a square minus b square. So you eventually get 81 minus 80. Okay, shown. Not shown. They say in this form. Okay, we stop here. You have your snack break. We'll continue later. We have a few more questions.
I also don't understand how to do like other CMU.
Solving equation.
Yeah.
Okay, I'll go through some, not all right. That means today we cannot start new chapter. Because I need to go through so many. Huh? Can you like not what? Yeah, so we will most likely end off with the quiz, but not new chapter. But can I pass you all the notes first? So I don't have to carry back. Okay, I give you all the extension worksheet for. This one is the homework. If tomorrow touch wood rain, right? Then this will be your home HBL homework. If it doesn't rain, this is your weekend homework. Yeah, same but different. Choose from. Two of you. Yeah, you are. Okay, this one is homework for the weekend. Anyway, I set up the chatbot for the AI chatbot for search. So this weekend, if you are very stuck, you can engage your AI tutor in Google Classroom. I thought I gave enough. Jeff and Raj, how? Anybody will see them and pass to them tomorrow. Who? You don't have? Yes, for Raj. So tomorrow you see him, then you pass him at the finishing line. Yes. Oh. For one, wait, what's the matter? Sorry. That find the solution to this. Group the x together. Take out the x as a common factor. Then the whatever cert inside, right? Right. And extract x as a common factor, take out first. Then 4 root 3 minus root 3 is 3 root 3, right? Bring the 3 root 3 down to the right. Then go and rationalize. Okay, actually from the very first step, right, you do this. Can it's your break time. Take out the x. No, this is the worksheet. Yeah. Then bring this putting down. And go and rationalize or simplify. Yeah. Too young, I will give you this. Okay, this one is the note for next week. I give you first, okay? Then I don't need to carry back. No, it is email coordinate geometry. Y equals to mx plus e.
Yes, something simple, right?
Yeah,
It's gonna be simple, right?
it's the simple one. This one is your happiness.
Assignments but not specializing.
No. Why I pass down? You don't have enough again? Oh, yeah. Oh, Jeff?
Anything that isn't biology.
Oh, yeah, that's that. Raj.
That guy is the best.
Okay. Need the
Also, when they also they are the
Why is she sleeping under? This is not the time to come out now. I think we need it. I think these
math and science.
might be strong. Let's
My first time having science and then now you I have the charm. We know it's you pass with you pass pass chemistry. I think it's time for you to get
Oh, it's another. Let's see it from No. Get up like grass, bro.
Okay, let's come back. Time flies when you're enjoying it. Okay, ready? Wake yourself up, pull your head up. Okay, area of the triangle STU is square root 54. Question 8.
So the area is first.
Yes, and then we make use of area formula. Half times base times the height and it will give us this. Okay, in fact, this one I can split 9 and 6. So actually, this is 3 root 6. So let me simplify it instead. Okay, so how to simplify the whole problem? I want to divide by half. So divide by half is as good as multiplying by 2. Okay, and then I want to divide this whole thing over. So become this. So this is my expression on the right for y. So this is 6 root 6. Root 6 minus 3. So I want to rationalize it by multiplying by its conjugate pair. Yes. First thing, I want to divide by half. So divide by half is as good as multiplying by 2.
Oh yeah.
Yeah, divide by half, you keep change flip is times 2. Okay, and then I want to divide this thing over. So become here. Okay, so how to simplify? This is 2 times of this. That's why I get 6 root 6. This thing I just copy down only. So I multiply by its conjugate pair so that I can rationalize my surd. So this will become root 6 square minus 3 square. The top part will be 6 times 6 and 18 root 6. So you should eventually reach 6 minus 9 minus 3. Okay, so divide everything by negative 3. This one will become minus 12. This one will become minus 6 root 6. Okay, that's it. I got a negative wrongly. Is there anything I wrote wrongly?
Oh no, this one.
Where's the error?
We don't. It's. Oh no, question A.
Wait, something wrong? Because I cannot have a negative answer. Where's the problem?
Is it when you square the numbers?
Minus b square. Question 8. Where's my error?
The square when you square it. Minus 9. 6. Oh no, that's right.
No, it's correct. Square root 3. Oh, it's a square root 3. No wonder. Okay, so that means this will have a change.
A small percentage change. Will the volume of that also change?
Yeah.
Negative 3 squared.
So this one will just be 3. Positive 3. Okay, then the top is 6 times 6 plus 6 root 18. Okay, that's your answer. Okay, double check. This is your question 8 answer. Okay, double check. Okay, next one, triangle ABC, right angle triangle. Find the value of AC squared. Yes, can. Okay, AC squared is Pythagoras theorem. So it's AB squared plus BC squared. So basically they want you to square these two. Okay, so this one is by Pythagoras theorem. Yes. Because this is 3. 6 times 3 is 18 divided by 2. Divided by 3. Eh? 6, sorry, 6. Wait, this is 6, right? 6. Yeah. Why is it positive? It's minus. Square root 6 when you square it is 6. Square root 3 when you square is 3. So 6 minus 3 is 3. Yeah. Okay, so this one a quick one. 20, 12. This one is 4. 4 root 3 and a 3. So simplify everything. 25, 37, 41, 44. Okay, so you should end up having 44 minus 16 root 3. Yeah, correct. Then part 2, find area. Half times base times height. So this one I think no need me to go through, right? You just have to expand and then eventually get this as your answer. Okay, so this one I leave it. Okay, what about the second PMP? Which question you need me to go through?
The second question.
Question 2.
Question 2 onwards.
2 and 6. Okay. Onwards is too much.
2, 4, 5, 6.
What? Okay, 2. Okay, don't do 3. Okay, can. 2, 4, 5, 6. Like that, I got time for quiz.
I want to understand.
So it's a scheme.
No, Miss Wong. I want to. If I don't understand and I do the quiz, there's no point of a quiz. I'll say it. I just want it.
If I suddenly cough blood, you are one contributing factor. Sure, fine. Are you okay? You don't even have your notes on your table, you just talk only, right? You from NATO, right? No action, talk only. You copy with your eyes, is it?
I'm understanding what you're doing.
Wow.
I don't pay attention. You're at attention.
Yes, from these two.
Okay.
Done not, done not. Done, See Raven, Ravan. Ayo, very Italian like that. Welcome back. Fast, I go through, then you all go toilet, then say don't want quiz. Nonsense. The certs.
He only comes in one day. How much? No.
Okay? Question. Okay, look at equations. Okay, shh. Listen, Equation only focus on two things. When one side of the expression has a square root, or both sides of the equation has a square root, you basically need to square both sides to get rid of the square root. So this is the first one. I make a poster for you. Okay, so that's the first step. Next one is if both sides are of the same form, you can just do a 1-to-1 comparison. So that means this number must be equal and this number must be equal. It's by the equality property. So if I give you an expression, a plus b root 3 is 5 plus 3 root 3. Then I can compare and tell you that a must be 5 and b must be 3. So this is by the equality property. So the whole 3.2 revolves around these two. Okay? And the whole 3.1 revolves around the 3 property I told you just now. That's all.
What is this? A plus B plus C squared.
Then you can simplify the numbers together. Yeah. Okay, so first thing first. First question. To get rid of the square root, what should I do? Square both sides. So x is just 25. Done. Okay, same thing. To get rid of the square, I square both sides. Okay, I square both sides and then I solve for x. Okay, for part C is a little bit different. Don't be eager to square immediately. Bring one of the square root to the other side first, so that you can get rid of two of them at the same time. So I'm going to square both sides now. Then the square root disappears. Then there will be another question that we need.
Can't we just square root x plus 2 and minus 3?
Which one?
Can we square all the terms first?
Straight away.
Yeah.
Okay, if you square this, remember, a minus b square is a square.
Not like that, like square a, then square.
We cannot split them. When you square, you need to square the whole thing. So when you square this, actually you introduce a middle term that you don't want. So you end up having this. You end up having this, but the middle part is the disgusting part that you don't want to handle.
No, I'm talking about like just do a square and b square.
Where?
Like just square square root of x plus 2, then square negative.
I cannot square things one by one. I must square the whole thing together. Yeah, it cannot be applied this way. Okay? So when you square them directly, you will end up introducing a term and complicate methods. Okay? So you got to do it the right way. Same thing here. Bring the 2 root x to the other side first before you square. So when you square both sides, square root disappears. Okay, then take note, you square both of them. The 2 you got to square, the square root you got to square. So this is where it always goes wrong. Yes. Yeah. Yeah. Yes. Then went toilet.
Those are not highlighted.
I'm not highlighted. Harita and Hashi. Amishi. Amishi and Christabel. First 2 in the list. The next 2. Next 2 is Harita and Hashi. So Amishi and Christy, go for your dental checkup now. No WA. Yeah. Okay, go. Go. Oral health is important too. Okay. Shh. So when you start solving this, 2x is -4, so x is -2. Solving, I'm not worried. It's just how you simplify the problem. Yes. If I put -2 into this, oh yeah. Good observation. Hey, did I solve it wrongly? Wait. Yeah, x cannot be -2. Otherwise, okay, yeah.
Do you square -2 or do you square just
You square the whole thing.
then shouldn't you
No, the negative bring over become positive already. Okay, take note, Harita just had an observation. If we try to sub in this back to the equation, do you realize that actually this is a forced solution that don't work? Because when you put in this as -2, it will give you no real roots. So actually this question is nonsense. That means when we craft this question for you, There's no solution for it. So when you have this situation, actually, right, you can sub this back to check, and then you realize that this one has to be rejected and there's no real roots for this equation. Okay, so this question has no real roots. Okay, but you won't be asked in this way, just that this question has issues. Okay, if not, you check all these, it should have a solution. Okay, so this just happened to be one question that should not be there. Okay, this one, I'll come back to it in a bit. You realize that you have 3 square root, then how? Okay, so this one we deal with it first. This one is the easier one. Okay, and then you square both sides. Okay, always sub back and check. Okay, so in the situation where we have 3 square root here, what do we have to do? So normally, you will have to square the expression twice to finally get there. So first step, you simplify first. Okay, we like to deal with positive more than negative. Oh, this one is a simple one. Yeah, this one. Okay, this one's simple. Okay, we simplify this. I thought this one is the difficult one. Okay, so 2 of root 3 and 1 of root 3 is 3 of root 3. You simplify first. And then you square root. You square both sides. Okay, so this is the answer. Not so exciting, the question. I must come in with some special ones later. Okay, so this one is using square to get rid of square root when you are solving. Nothing scary. When you are done, flip to the next page. That one is comparing. Okay, we will compare. Okay, so later during the next double period, we will do all the PMP. Whatever you can't complete becomes homework. So let's make it constructive. Can? All good? Okay, next one. This one, just rearrange them and compare. A plus 5 root 3 minus 2 plus b root 3. So you observe, A is just minus 2 and B is just 5. That's all. Don't work too hard. Okay? Compare. Same thing, right hand side, go and expand first. And then simplify. Then now you can compare term by term. So H is 3 and K is the number in front here, which is a 1. Okay, very, very simple and direct. This one is on Shijiangmukdo. And Asheville also. They went overseas? Yes.
Astro is sick. Wait. Where did I go wrong?
You cannot square them separately. You bring over here first, then it becomes 3 root 3, then you square.
Oh, you have to times.
Yes. No, you bring over and plus first.
Oh.
Yeah.
So it's
2 root 3
2
plus
square
3 root
root
3.
3 plus square root 3.
Yes.
So it's
3 square root 3. Then you square both sides.
2 square root 6.
When you square both sides, become
Wait, so you bring this negative to here, then it becomes 2 square root 6.
no. 2 square root 3 plus 1 square root 3 is 3 square root 3. Square root 3 is like an x.
Oh.
Yeah. Okay, last one. This one, same thing. You have 2 square root. Bring 1 to the other side first. And then now you square both sides. Okay, so when you square both sides, the 3 you got to square it. The square root disappears. The minus 1 you got to square it. And then the square root disappears. Okay, 2. So simplify everything. Okay, then the rest is just normal solving. You can use quadratic formula. Oh. I do wrongly. 25, 26. Okay. Okay, so what's the 2 answer? What? 2 and minus 3. Okay, so 2 answers. Okay, so the remaining 6 minutes, you can get started on the PMP on page 5. First, on to this. Okay, let's look at one. Not yet. Okay, 2, a very quick one. You all know next time you go JC, go poly, go uni, the lecturer will not wait for you. Okay, first thing first, rationalize both the fraction. So make this 1 plus root 2, 1 plus root 2. Then the second one, you introduce 3 minus root 2. So the right side, don't do anything. You are supposed to compare later. So rationalize the first one. You will end off with this. Okay, rationalize the second one. Okay, so just keep copying down the right hand side. So actually, right, this is 1 minus 2 is a negative 1 on the bottom. When it's negative 1, you just reverse the sign of everything on top. So become minus 1 minus root 2. And then denominator is gone. Okay? But this one is 9 minus 2. So it's a 7. It's a 7 at the bottom. So in order to simplify it, you want to split this into 2 fractions. So this is this and this. You can always split them back into two. This and this. You combine them back, it's the same thing. Okay? So how do you finally simplify it? You will get this thing. Okay, so if you want to do comparison, you just compare the constant term with the root 2 term. So that means A must be equal to this one and this. This is A value. So A is actually minus 1 plus 2 over 7. Okay, I simplify for you. Let's simplify the left hand side, this one. You will get minus 5 over 7. You simplify this, you will get, let me take out the root 2. Okay, I'm just simplifying what is on the left hand side. I group the like terms together, the constant term and the term with the square root 2. So can you see that actually A takes the value of this number and B takes the value of this number, which I haven't simplified. So A is just minus 5 over 7 and then B is just minus 1, 3 over 7. Okay, so no matter what, they want you to rationalize somewhere. You just rationalize them one by one. Okay, 4, 5, 6 is the same thing. So no need already, right? Or still need? I got a feeling you're all trying to. Okay, I do 4 for you, 5 and 6 all at the same time. Let's save some time. I just tell you the technique. You're scheming me, right? Okay, this is 4, 5 and 6. Okay, if you look at the question, okay, they want you to make this into this form. It's the same thing actually. Okay, can you see some similarity in what they are asking you to do? They are asking you to simplify the left hand side and then compare with the right. So if you look at question 4, what you can do is to rationalize this one. Okay, you rationalize the fraction. You get 6 minus 3 root 3. And then the bottom is just this square. Go and expand this out. Yep. What do you mean do to the other thing? No need. Okay? So the only thing is to rationalize the fraction and then you end up having 4 minus 3. So this is just 1. There's nothing to change. Because it's 2 square minus square root 3 square. 4 minus 3. Okay? So this one, I leave you to go and simplify. You can solve for the P and the Q. It's the same thing. Okay, right hand side, the left hand side, this one same thing. Go and rationalize by multiplying by its conjugate pair. Okay. So go and rationalize by multiplying by the conjugate pair. So what happened is you just do your normal expansion, Denominator become this.
Wait, Miss Wong, shouldn't this all be a plus?
Where?
The top, it should be a plus, not a minus. The conjugate pair should be a minus, plus.
Oh, this one. Okay.
Oh, nice catch.
Okay. Okay, then go and finally simplify it. Bottom is 18 minus 12. So that is a 6. Okay, you can use calculator for this one. And then the top part, go and break it up. So breaking up, you should be very good at it. Okay, so I leave you to simplify and then compare with this. So there's nothing extra already. It's all the same technique. Keep rationalizing. Can or cannot? Can, good. Quiz.